The modern global economy rests on an incredibly fragile foundation located just 100 miles off the coast of mainland China. Taiwan has transformed itself from a regional manufacturing hub into the absolute epicenter of the global semiconductor supply chain. This concentration of high-tech production creates an unprecedented level of international economic codependency that defies traditional geographic boundaries. Every major industry, from automotive manufacturing to consumer electronics, relies directly on the uninterrupted output of this single island. In 2021, Ford had to park 60,000 unfinished F-150 trucks in Kentucky fields. Not because of steel, not because of workers. They were missing a $1 chip made in Hsinchu, Taiwan. That image, trucks worth billions waiting for silicon, is why generals now study supply chains. At the absolute center of this technological matrix stands Taiwan Semiconductor Manufacturing Company, commonly known as TSMC. By capturing over 70% of the global foundry market as of 2025, the corporation dictates the operational tempo of global innovation. Unlike traditional tech giants that design their own products, TSMC pioneered the dedicated foundry model to manufacture complex chips for other companies. This unique industrial specialization allowed the company to refine its fabrication techniques to a degree that no foreign competitor can currently match. While many nations possess the capability to manufacture legacy semiconductors, Taiwan maintains an absolute global monopoly on advanced nodes. TSMC currently controls roughly 90% of the production capacity for critical components fabricated at 7 nanometers and below. These highly advanced microchips serve as the foundational architecture for the world's most sophisticated technology ecosystems and consumer devices. This immense concentration of production means that a sudden halt in Taiwanese manufacturing would instantly paralyze global technological progress. TSMC was not born powerful. In 1987, founder Morris Chang flew to California with a strange pitch. "Give us your designs, we will not compete with you." Intel laughed. Apple listened 30 years later. Today, that promise is why Apple cannot build an iPhone without Taiwan. The strategic importance of Taiwan became visible during the global semiconductor shortage that emerged after the COVID-19 pandemic. Automobile manufacturers across North America, Europe, and Asia were forced to slow or halt production because critical chips were unavailable. Vehicles worth tens of thousands of dollars sat unfinished, while manufacturers waited for components that often cost less than $100. Ironically, the shortage was not in the most advanced 3-nanometer smartphone chips, but in simple 40-nanometer microcontrollers. Yet those too are made in Taiwan. The crisis exposed a fundamental reality of the modern economy. Advanced industries are no longer constrained by steel, aluminum, or energy. Instead, they are constrained by tiny pieces of silicon manufactured in a handful of highly specialized facilities. For policymakers in Washington, Beijing, Tokyo, and Brussels, the shortage served as a warning. If a temporary disruption could cripple global manufacturing, a major conflict in the Taiwan Strait could create an economic shock on an entirely different scale. However, the strategic value of this territory extends far beyond the perimeter of its sterile semiconductor cleanrooms. Taiwan sits squarely in the middle of the first island chain, serving as a critical geographic barrier that contains the Chinese mainland. If Beijing were to successfully annex the island, the People's Liberation Army Navy would gain unrestricted access to the deep waters of the Western Pacific. This shift would directly threaten critical sea lanes, place extreme pressure on Japan, and leave American military installations in Guam highly vulnerable. The semiconductor competition has fundamentally evolved beyond smartphones into the high-stakes realm of artificial intelligence. Training frontier machine learning models requires enormous quantities of advanced graphics processing units fabricated almost exclusively by TSMC. Companies such as Nvidia, alongside numerous hyperscale cloud providers, depend entirely on Taiwanese fabrication plants to sustain the exponential growth of computing power. Consequently, Taiwan has become the critical geographic choke point through which the entire future of global artificial intelligence must inevitably pass. When OpenAI trained GPT-4, they did not wait for code. They waited for a shipment of Nvidia H100s from TSMC Fab 18. Jensen Huang admitted publicly, "We are sold out for the next 12 months." The bottleneck was not software, it was a clean room in Tainan. For most of the 20th century, industrial power was measured by steel production and oil consumption. In the 21st century, strategic power is increasingly measured by computational capacity. Artificial intelligence models, advanced military simulations, autonomous systems, and next-generation scientific research all require enormous quantities of advanced processors. Every major AI breakthrough today depends on access to advanced hardware, and that hardware is almost exclusively manufactured in Taiwan. Regardless of whether the software originates in Silicon Valley, London, Paris, or Beijing, it must eventually be translated into physical chips made in Taiwanese cleanrooms. This reality transforms Taiwan from a simple manufacturing hub into a strategic gateway for the global AI race. The future balance of economic and military power may depend less on algorithms themselves and more on who controls the facilities capable of producing the hardware that runs them. This advanced processing capability directly translates into hard military superiority for the United States and its allied nations. Modern military hardware relies completely on advanced semiconductor logic to function effectively within highly contested multi-domain combat environments. The guidance systems of fifth-generation aircraft like the F-35 Lightning II require custom-fabricated integrated circuits to process massive amounts of sensor data. Advanced kinetic weapons, autonomous drone swarms, and encrypted command networks all depend on silicon that simply cannot be substituted with legacy components. Recognizing this critical vulnerability, the United States initiated a massive effort to reshore semiconductor manufacturing through the CHIPS Act. Billions of dollars in federal subsidies were allocated to construct new mega foundries within the American desert, specifically targeting the state of Arizona. However, replacing the highly optimized Taiwanese ecosystem on foreign soil has proven to be an incredibly complex and heavily delayed challenge. By the time these American facilities mass-produce 4-nanometer chips, TSMC's domestic operations in Taiwan are already advancing toward 2-nanometer risk production. In Phoenix, Arizona, TSMC engineers brought their 12-hour shift culture. American technicians quit after 3 months. One manager told the Wall Street Journal, "We are building the most advanced factory in U.S. history, but we cannot find people who want to work in bunny suits." That culture gap is why Arizona is still 2 years behind. Constructing a leading-edge semiconductor fab costs over $20 billion and takes half a decade. Yet even that massive undertaking is still easier than replicating the entire ecosystem around it. The true advantage of Taiwan does not come from a single building, but from thousands of interconnected suppliers concentrated within a few hours of TSMC's facilities. Specialized chemical manufacturers, precision equipment suppliers, wafer inspection firms, and packaging companies operate in a tightly integrated network that has evolved for more than 4 decades. When a production problem appears inside a Taiwanese fab, engineers from multiple suppliers can often arrive on site within hours. Replicating this level of industrial density in Arizona, Germany, or Japan requires far more than money. It requires rebuilding an ecosystem that took over 40 years to develop. This hidden network explains why semiconductor leadership is measured in decades rather than years. The challenge is not constructing factories. The challenge is recreating an entire industrial civilization. Beijing faces its own severe strategic paradox regarding this technological bottleneck. Despite injecting billions of dollars into domestic foundries like SMIC, China remains trapped in a technological cul-de-sac due to international export controls. They are completely blocked from acquiring extreme ultraviolet lithography machines, effectively capping their mass production capabilities far behind the Western standard. An invasion would trigger immediate sanctions that would cripple their domestic tech sector, while capturing Taiwanese foundries intact is practically impossible due to their extreme physical fragility. In 2023, Huawei shocked Washington by launching the Mate 60 with a 7-nanometer chip made by SMIC, despite the ban. U.S. analysts tore the phone apart in a lab. Industry estimates suggest SMIC's production yields remain significantly lower than TSMC's, resulting in substantially higher manufacturing costs. It was a propaganda win, not a production win. That is the cul-de-sac. This delicate geopolitical trap is formally conceptualized by defense analysts as the Silicon Shield doctrine. The theory posits that the global economic consequences of an invasion are so severe that they effectively deter aggressive military actions from all sides. Independent economic modeling estimates that a full conflict over Taiwan could destroy up to $10 trillion in global wealth, representing 10% of the world's economy. This framework of mutually assured disruption ensures that a blockade would not only crash American markets, but simultaneously devastate China's own manufacturing export engine. The ultimate question remains whether the United States could survive the sudden loss of this critical island partner. From a purely long-term perspective, America could eventually rebuild its domestic supply chains and recover from the initial technological shock. However, the multi-year transition period would trigger a catastrophic global depression and temporarily cede military technological dominance to strategic rivals. Ultimately, Washington is forced to defend Taiwan not merely out of ideological solidarity, but because the island physically manufactures the future of the modern world. The real lesson of Taiwan is not that one island controls the future. The lesson is that globalization concentrated the world's most critical technology into a single geographic point of failure. Whether the future belongs to America, China, or another emerging power may ultimately depend on who can build resilient supply chains before the next crisis arrives. Taiwan is not merely a territory. It is a warning about how fragile the modern technological world has become.